Okay, 11:05. Pavel, are you ready?
Yeah, I'm ready. Hello, once again, I'm Paul, and I've got the pleasure to prepare and present to you also the technical part of this whole webinar. But of course, for now, Peter is going to lead this presentation.
Yes. Good morning, everyone. Once again, thank you for joining us today. Today we would like to present you the automation in 3D scanning and how to improve and speed up inspection process. The webinar is divided for three parts. First will be the presentation of SmartTech 3D company, who we are, what we do, why we do that. Then Pavel will present the technical presentation for you with our two devices. And the last part, the third one, will be Q&A sessions. So please write your questions if you have in a chat box. So we are SmartTech 3D, a producer of structured light 3D scanners. Our company was founded in the year 2000. Here you can see our headquarters and our team, along with some of our partners, because we have a net of distributors all over the world. Generally, we are focusing on obtaining 3D data from scanners, and we are not only producers of 3D scanners, but we are also a problem solver. So if there is any kind of issue with inspection, with reverse engineering, we are willing to help to solve the problem using our technology. Here is our board of directors, Professor Małgorzata Kujawińska. She, with her team, invented the technology on the University of Technology in Warsaw. Anna Gębarska, who is managing director, and our CEO, Chris Gębarski, who transferred the technology to the final product that is 3D scanner. What makes us unique is, first of all, high resolution. We can deliver the highest resolution on the market, 24 megapixels. However, depending on the model of the scanner, we use different resolutions of camera. We started from 1.3 megapixels and even up to 24 megapixels. We are not only producers of hardware, but we are also developing our own software, which is generally the heart of our system. What makes us really unique is that our technology is prepared to scan also with color. So we can grab not only geometry of the object, but we can also grab the color of the object in RGB formats. All our devices are metrologically certified accuracy according to VDI, VDE certification. And the last unique feature is projecting color map of deviation directly on the objects. During 24 years of our company, we had a lot of very interesting projects and a lot of very interesting customers like NASA, US Army, General Electric, Opel, ABB, and Boeing. Here we have the full range of our standard product. We generally divided our range of products for two different lines: industry and technical applications and non-technical applications. Industry and technical application, our king of scanner, Micron 3D Green Stereo, with the highest accuracy and the high resolution up to 20 megapixels. The second scanner is entry-level reverse engineering and quality assurance scanner, which is called SmartTech 3D On. The next one is SmartTech 3D robotized, special scanning heads, generally directed for working with robotic arms. We also have in our range of products SmartTech 3D photogrammetry sets. This set allows us for measurement big objects like car bodies. Today, I would like to focus on two our solutions, SmartTech 3D CobotScan and Quality Station. Those two scanners are prepared for automating the whole process of 3D scanning. In non-technical application, we have two scanners, SmartTech 3D Med for medical purpose, and also Micron 3D Color, which is dedicated for museology and archaeology. Both of these scanners can capture also color. So here, shortly, I will tell about Quality Station. Quality Station is a set of SmartTech 3D On scanner combined with rotary tilting stage. Thanks to that, we can do the 360 scanning of the object, but we can also tilt the table to grab the information from the bottom of the object. Applications for the scanner is mainly for quality control and reverse engineering. The light source we use here is a green light. Accuracy starts from 31 megapixels, and we use here cameras with 6 megapixels of resolutions. We have two different field of view of the scanner, so 150 by 113 millimeters and 200 by 150 millimeters. Here we have our latest scanner, SmartTech 3D CobotScan, the smallest scanner in our range of product. It needs to be small because it's dedicated to cooperate with cobotic arms. Application is automatized reverse engineering and also quality assurance. What is interesting in this scanner, we can use green or white lights because this scanner can also be upgraded to RGB color scanner. Accuracy here, we start from 18 micrometers, and the resolution of camera is 5 megapixels. We can have three different fields of view of this small scanner. Here's some application when we can utilize our scanners. Here we have reverse engineering of propeller. The aim of scanning this object was to change the thread of this propeller from left to right. So what we did, we used CobotScan scanner combined with rotary stage to grab the information about the object. And then in external software, we did the whole reverse engineering process. Here is a very interesting project for General Electric. It was automated defect detection. So we used our biggest scanner, Micron Green Stereo, combined with huge robotic arm to inspect those turbine blades from jet engine. And the last one, I think the most interesting case, because we need to scan very big objects, 1.5 by 2 meters, and we combined two scanners to do this. But Pavel will tell you a little bit more about the project during the presentation. So thank you very much for now. Please, Pavel, show our scanners.
Hello once again. For now, I'm going to share you my screen so you will be also able to see our SmartTech 3D Measure software, not only the hardware, but basically how it's going to look like from the beginning to the end. I would like to show you actually everything, how we are scanning our samples, and then what we can do with the data that we are going to obtain. I hope everything is visible for now. So before we will make everything, all the automation, I'm going to tell you a couple of words about this quality station, about the hardware. So what we've got out there, it's like Peter mentioned before, we've got SmartTech 3D on model of the scanner set on this arm, and the arm is connected also and assembled with the rotary tilt stage. With that system, we are able to scan really automatically a lot of different samples and specimens. Of course, the key out there is going to be the size of an object. So we can fit out there between those two tilting arms samples up to the 200 millimeters. So out there might be some small, rather smaller things than the bigger one. But of course, if you like to scan even bigger objects, we've got another solution that I'm going to talk a little bit more in the second part of this technical presentation. Right now, we are focusing on the quality station. In a moment, I'm going to tell you more about the cobot system solution. So going back out there, we are going to scan our sample. Over here, we've got the green light scanner with two detectors and one projection module in the middle. I hope most of you know how the structural light scanners works, but just to make one explanation, we need to project the light on the surface of object, and then detectors are grabbing those informations. They are going to be transferred to the workstation that I've got out there. And in the end, we'll be able to prepare the 3D visualization in our SmartTech 3D Measure software. So let me show you how basically it's going to look like. Of course, if you'd like to in our software check how generally the whole sample looks like, you can always make the live view mode just to check what is visible for both of those detectors, the lenses out there. When we'll know everything will be set up, we can, for example, use the tilting model just to change the angle of our sample. And thanks to that option, we are able to get deeper, for example, to the holes. Or if you'd like to, we can see, for example, the bottom part or the side of our object. Previously, if you would like to, for example, use the manual rotary stage or just the automated rotary stage, it needs to be some point of the connection between the sample and the ground. In that case, we can, for example, tilt it, and then we'll be able to scan it scan the data that is at the bottom part of our object. Let me show you how generally this scanning works and what we need to do. First thing, we need to press start. Right now we are starting the projection on the surface of our object, and in a second we are going to have the visualization. The visualization will be, in that case, always the same. So those are the raw data points cloud. When I will zoom in right now, for example, from this point of view, everything might look like the surface. But when I will zoom in, we can see that we are working with the millions of points. And they are important for us because according to those points, we are able to make some kind of the measurements. And another important thing for that object is going to be, for example, measuring the scanning resolution. So for example, depending on the field of view and the resolution of the cameras, we are able to obtain a much better scanning resolution, and it's going to be, in that case, for that scanner, distance between the points equal to 86 micrometers. So by making this field of view smaller, we will be able to have a smaller distance between points, and this means we will be able to get more information about small scratches, dents, or defects. For the inspection and quality control, it's really important, and in some of the cases, it might be crucial. So when we know what we need to do at the beginning, we are scanning, then we are collecting the points cloud as the raw data. We can also make the post-processing. In our software, it's possible to do it manually with for example, all of those applications in the points tab. Then we are going to transform everything into the triangle mesh.
in our triangles tab, but we are going to focus on the automation. So we would like to make just one click, one button, and then everything will be made automatically. So to do it, we are going to the automation tab, and we need to select from the menu or like dozens of those applications and dozens of those automations. So for example, if you are working on the line production and uh, you would like to just simply inspect a lot of similar objects, but with some small differences, you are able, for example, to prepare the special automation for each of those samples. And then you can simply connect them or, for example, find out in which category you would like to set this parameter. What we've got out there is going to be the full process. So first, we are going to scan our sample. Over here in this box, you can see that we have prepared three, I would say, stages of the measurement. First one is going to be the full rotation with the step of 60 degrees and the tilt equal to 20 degrees. Then we are going to change a little bit the angle just to obtain some of the data that weren't properly visible for the detectors because of that angle. And that's why we are changing it. In the end, we are going to set the minus 60 degree of the tilt to obtain some data and get some data about the bottom part of our object. After this process, we are going to have the post-processing. So, for example, global alignment, removing some of the noises that are all around because of the, of course, environment, some extra light out there, just so you will be able to see us clear, and the really high sensor sensitivity. It's important because today, most of the cases and a lot of samples are rather dark than bright. So sometimes we need to increase the sensor sensitivity to get some extra information about the sample. So that's why for now we have some of the small noises all around, but thankfully, the automation process will also remove them automatically. So you don't need to worry about them. Everything will be automatically cleaned up and transformed to the triangle mesh. The triangle mesh, then, we are going to use this STL file for the advanced inspection, measuring some distance, checking if some of the surfaces are parallel or not, etc. To do this, I'm going to use the Geometric Control X software. It's going to be, I think, really easy option out there, because basically you need to open the Geometric Control X with ready project with some measurements that we prepared before, importing, so actually replacing the data, and then by pressing one button, once again, you will have the full measured object, full inspection, also with the PDF report. Of course, in our SmartTech 3D Measure software is also possible, but if you would like to make advanced measuring, for example, having the GD&T module, then we are using simply Geometric Control X. So right now, as you can see, we are at the first stage of the full measuring process. So we are making the measurement with the different angles and different positions, just to build up the raw data from all of those sites. Then, I hope that you can see it, we are not using any kind of the markers, reference points, because we are going to align all of those clouds according to the geometry of them. So as you can see also out there, second stage is going to be the global registration, just to connect, use something like the best fit to get all of those data stick together, and then we'll be able to make and have even better accuracy according to this full object. Of course, if you would like to use the reference points, markers, or geometrical markers, it's also possible. We are not like removing this application from our software. We wanted to just add another possibilities of the measurement systems for the customers who like to have 100% of the inspection of the surface. Of course, if you put some stickers, then we're covering some of the material that sometimes might be crucial for the customer's wishes. Okay, right now we finished the measuring process. As you can see, rotary tilt stage is going to the home position, 0 degree of the tilting angle, and we are starting the aligning points cloud and everything. For now, I think we will have around 2-3 minutes until the full, like the computer and workstation will calculate and clean everything. So I think it's going to be a good idea just to, for a second, come back to the special project that we made before, and I'm going to explain you what we need to do out there and how Generate looks like. Can I ask Peter to open the presentation on that Renus Opel Rosenheim factory project?
Yes, the presentation is open, and maybe Paul, you can also tell something about why the automation of the process is so important and what we improved in this process.
Yeah, of course. So maybe let's start, for example, with the explanation what we need to do out there and what kind of the devices we had to use. We've got some kind of the inquiry about the special system for the quality inspection of the headlines for the Opel manufacturing. Over here, one of the most important things, according to the inspection, was the position of those blue sponges, foams, and they need to be glued in the very specific way and also specific position. So, of course, it was everything made on the line production. So we need to build the special system. We've got some kind of the gate, and at the top of those gates, there were hanging two of our scanners. They were facing down, and the line production just moved from one side to another one. And when the headline was exactly below of our scanners, we were starting the measurements. And you may ask, for example, why we have two scanners. It's because of the size of our object that we were actually inspecting out there. So you probably know the accuracy is dependent on the field of view. So if you would like to increase and extend the field of view, then we can lose some of the micrometers of the accuracy. So instead of that, we wanted to, and we find out that it's going to be a better idea to use two separate devices, but assembled together in one system. Thankfully, our SmartTech 3D Measure software allows us to combine two or even more devices from many different angles, just to simply make the scan in the same time and automatically align all of those scans. Thanks for that, even bigger objects, headline size, or for example, car size, might be scanned just with the 1, maybe 2 seconds. For now, of course, we've got a little bit faster process of the scanning, but out there it was 16 seconds. After that, after the measurements, the line production went to the next position, and during the movement, we were making the calculation. So we compared the data with the reference ones, for example, CAD model or some special prepared real object, because we can also compare the data, the raw points data, to the ready STL file. So you don't need to always use the CAD model if you, of course, if you are sure that the sample is have the correct dimensions. And then we were making the PDF report. So over here, I hope you can see, we've got with this red color selection of those, the position of those sponges. And we need to find out if each of those foam sponges were set in the correct position according to the X and Y axis. Fortunately, depth wasn't important out there for our customers, so we could focus most on those two axes. And the full, I would say, inspection, it was around 1 minute. Previously, there was a special employees that needs to actually inspect that elements and make the quality control on their own. And you may imagine that it took much more time. So for the conclusion for that part, automation mostly is for saving the time. And we know that the time is actually the money for the industrial sectors. So with the automations, you don't need to, for example, maybe it's not going to, but you don't need to pay actually for the really trained engineer, because our software can do everything out there with just one click. And in a moment, I'm going to also show you how to make the measurements. So you don't need to be specified in the metrology sector just to, for example, see on the PDF report if the sample passed or not passed the test. So I think it's going to be this is the most important case for any kind of the automations. You can, for example, have more time for another R&D sector thinking, or just simply measure more of the samples in the same time that that, for example, you will have to do it without the automation process?
Yes. So automation allows to save time. That's the first thing. The second thing is, as Pavel mentions, there are lack of qualified technician for operating scanner. Automation not only save time, but also makes the process really easy for scanner operator, and of course, it's cost effective.
Yeah. So
Okay, for now I shared the screen once again, so you can see the results over there. So I hope you remember couple minutes ago, we've got a lot of noises all around, but thanks to the automation that you can see out there, all of those processes was set before the making the automation. You need to do it only once. We've got much cleaner data, and let me show you what we've got out there. This is our project tree. Over here, we've got the points cloud as a raw data for each of those tilt positions, and you can, for example, zoom in, check that right now we've got millions of those points. They are aligned together, so we don't have anything like the overlays for that part. You can, for example, inspect even like the thread inside or some small parameters. Then when we will transform those data into the triangle mesh, for example, for the reverse engineering, preparing the documentation, is going to look like that. So we've got over here the surface as a triangle mesh. And in a moment, we are going to actually export this file to the GeoMagick Control X. I hope that you can see everything, but I wanted to mention one more thing. Of course, in our software, SmartTech 3D Measure, you can also make some measurements. So we need to go to the control, and for example, measuring the distance between those two surfaces, it's just simply selecting those two parameters, those 2 points on both of the surfaces. Over here, we've got the distance, and of course, we've got the distance according to the 3 main axes out there. If you would like to, we can also make a couple of the cross sections. So for example, we need to go here, select the cross section that we are interested in, maybe another one. We can, for example, measure the perimeter of them, or extend and actually export them to another external software. So this is what we've got from just a couple of the cross section. And maybe let's focus on the second one, because over here we can, for example, show you how we are measuring, for example, the perimeter. So over here we've got the 2D dimensioning. We can select all of those data, select 2 points, and we'll have the total perimeter of our sample. I'm pretty sure that it's quite easy to transform this value to the radius, for example, or diameter of the hole. We can measure the area or volume. So those are the most important things that we can measure, for example, in our system. But for the GD&T module, we are going to simply do like that. Let's change the name of our object, and for example, part 1. Okay, and I'm going to select it and export our triangle mesh into the STL format. We've got 3 formats: STL, PolyWire, or OBJ. Let's select the destination path. We've got automation, STL to inspect. Okay, let's save it here and press export. Okay, now let's open the folder where we've got our object saved. This is it. And we've got also our main project with all of the measurements. So we are opening the GeoMagick Control X, where we've got, for example, checking some of the diameter of our object, cylindricity, for example, perpendicularity, many different measurements that might be important on the line production and quality inspection. Right now, we've got our measured data set as the data that we were making before. So it's a little bit different name, but we would like to simply replace those measured data. We are choosing the part that we just made a moment ago, and we need to press run inspection process. For now, we need to wait a little bit. So the software is going to import the data from our made by our software, SmartTech 3D Measure. It's going to align them together and then follow all of those steps during the GD&T processing. So as you can see right now, we've got aligning by initial, aligning object, then we'll have datum alignment, and then preparing, for example, cross-section, color map of deviation, and working and making some of the measurements. So in a moment you are going to see it. Also, we've got the console where we can simply check at which stage we are right now, aligning by datum, and in a moment we are going to have everything prepared. So as you can see, if you will have your own sample, your own elements that you would like to inspect, the real work is going to be only at the beginning, where you need to, of course, find out what kind of the measurements are important for you and what would you like to inspect. But when you will prepare everything, the automation for in our software, SmartTech 3D Measure, for digitizing an object and grabbing geometry, then we will have our data prepared, and we are doing only once the quality inspection in the, for example, Geomagic Control X or any other software. And by pressing 2, maybe 3 buttons, you will have everything prepared. So as you can see right now, we've got group part 1. So this is the existing data that we've got before. Right now, this sample, it's not fitting into, and it shouldn't, it actually didn't pass the test. Like here, we've got a little bit different value than we've got before. It's of course different sample. So what we would like to do right now is going to be simply generating the report. So we are pressing here. In a moment, you can select between a couple of the modes or, for example, cross sections, every kind of the measurements you would like to have. You can also select over there. We are simply pressing generate. In a moment, we will have the refresh of the visualization. So we've got Axis Hub, SmartTech 3D, my name and surname. We've got those data. Let me save it. For example, here, part 1 and save. Let's open this folder once again. And of course, we will have our data opened as a PDF report. So it can be not just the pass or not pass report, but also the documentation for each of those samples. So we've got our CAD model, we've got our triangle mesh, it's aligned together, we've got some of the statistics out there, we can make the color map of deviation also with the statistics, and then we are moving to the finding out and measuring the real objects. So this is what we can do, I think, quite fast and without any kind of the knowledge for the professional using. So that's what we are capable to do with the quality control. And because sometimes we need to inspect bigger objects, I think it's going to be the best idea if we'll move to the SmartTech 3D CobotScan, where we can measure a little bit bigger or a little even bigger objects. So maybe for a second, Peter will take care of you. I'm going to swap on the next workstation, and then I'm going to explain once again what we've got with the robotic arms.
Thank you, Pavel. So as most of you probably know that every scanner has its own field of view, and there are some limitations using Quality Station. The biggest field of view in this scanner is 200 millimeters by 150. It's mainly because if we can, of course, increase this field of view, however, then the quality of the data that we received will be much lower. And the limitation is also the size of the rotary tilting stage. So that is why we have another solution. So CobotScan, it's a scanning head combined with cobots that we can use for measuring bigger objects, but also smaller as well.
Okay, so thanks you one more time. I'm going to share my screen also over there on that workstation. I hope everything is visible for now. And let me explain what we've got out there. Once again, starting from the hardware and then moving to the software. Like Peter mentioned before, we've got SmartTech 3D CobotScan. It is the smallest device that we've got right now from all of the list of our models. Over there, it's also stereo system with 2 detectors, 5 megapixels resolution, but it's going to be also possible to do it with the 6 megapixels resolution. It's assembled with the cobots robotic arm. To be honest, it doesn't matter what kind of the brand of the robotic arms you would like to use. We are able to integrate our scanners with any kind of the robotics. We are, for example, talking about Hans robot, Universal robot, KUKA, Kawasaki, anyone, like any kind of the robotic arms you would like to use, we will be able also to integrate it. Another accessory out there is going to be standard, like the automatic rotary stage, but the standard version. And to be honest, it's also increasing and like speeding up all of the automation processes. We will be able to do it without the automated rotary stage, but then the robotic arm will need to make much more of the positions. And with that system, we are using only the most critical. Let me show you and start the whole process. So we are going to automation, cooling system, apply. Generally the same method that we've got before. And right now I'm going to tell you. Thanks for that, we've got another accessory. We are able to, for example, prepare the station and positions for the robotic arm only for the most crucial angles where we will be able to obtain enough important data. All of the rest positions are going to be actually changed by the rotary stage, and it's much easier for us to do it this way. But of course, let's say that we've got the sample that will be the size, for example, car doors. Then we are also able to do it, and we don't need to use the rotary stage. Let me show you how it's going to look like. We've got the special video for you, and over there, this is the quality control of the car door. I'm going to explain a couple of the things during this video. So out there, we've got the universal robot, as you can see. And we wanted to inspect some of the critical areas on that car doors. So we scan it at the beginning with the 3 different places where we find out some critical geometry for the customer. Over there, we will have those 3 data also visualized in our SmartTech 3D software that you can see over there. They are not connected together because out there we are grabbing information about each of those coordinate systems according to the position of each of those joints in the robotic arm. Then we have imported the CAD model of our car doors for the comparison and to simply have the reference ones. We are aligning both of those coordinate systems together just to make sure that the measurement will be connected and is going to be made according to the reference parts of the customer's wishes. Then we were able to compare those data. So for example, comparing the points cloud, always the raw data to obtain the best precision and like the best accuracy for that. And then we repeat the whole process once again. So we were scanning in the same positions, and then we were able to make the comparison to actually make the color map of deviation like you can see right now on the screen. So if you like to speed up the process of inspection, in our cases, you may, for example, focus on the data that you are really interested in. You don't need to, for example, let me show you like one thing. You don't need to scan it from one side to another one. Like for example, you need to do it with the markers or stickers or any other reference points. You can just simply scan it out there, connect it according to the geometry, and measure the distance, for example, between those 2 or 3 holes. And for example, the center of them. So it may also speed up some of the processes. And thanks to the range of the robotic arms that you can also change, it's possible to scan much bigger objects. For example, that one range of this robotic arm is around 1 meter. So we've got the range up to the 2 meters, of course, 1 meter on the right side and the left side. You can also make the annotations and work with everything out there. I hope that you can see that the position of the robot, like our CobotScan, you can scan in many different positions, even if the scanner is set upside down. So it's also might help us if you would like to, for example, inspect and make the projection of the color map of deviation directly on object. So the whole set of the vibration plate and detector in our scanners allows us to find out if there are some differences according to positions of our robotic arm. And simply we don't need to worry about some small vibrations. And over there, we can also project the color map of deviation directly onto the surface of our object. So, for example, if you'd like to change the position, you can just find out another position and also project it on the other side. So that's what we are able to do, for example, with the bigger objects. Let's come back to our software and our system. And as you can see right now, we finished the whole measuring process. So right now we are at the third stage from 8 of them. First one, it was making the measurements, and right now it's going to be filtering. Right now, this process is much faster than just making the measurements. For that object, we need to have, as far as I remember, 4 or 5 positions, different angles of position of the scanner, and then we added just the simply rotation of the rotary stage. Another, I think, important and unique system out there is going to be scanning such samples for the automotive. This is actually the part of the cooling system for the engine in the Audi and Volkswagen group. So we didn't need to spray it anyway. It's the metallic part. There are some small surfaces that are quite reflective, but for that object, we didn't need to spray it. Thanks, for example, to the possibilities of changing the angle and scanning the sample from many different angles. So this is another advantage of using such devices. And because we've got out there small scanner with small field of view, we are able to get much better scanning resolution than, for example, with the SmartTech 3D On. But of course, the specification of each of those devices is dependent on the customer's wishes. We are able to make some customizations, and our programmist developer team can also insert and actually implement some kind of the applications or automated measurements also in our software. So for example, if you'd like to in the future have the PDF report with the exact dimensions, general dimensions of the sample, or for example, what will be the distance between 2 or 3 holes, we can also automate this process in our software. So right now we are finishing our scanning process and measurements. We are at the last stage, creating the triangle mesh. Of course, before that, we need to remove all of those noises. So for example, in the moment, you are going to see that such elements out there, they were automatically removed. And they appeared once again because of the high sensitivity of the scanner and some of the external lights out there. So for that moment, I think those were the most important cases. Perhaps appeared some of the questions. Maybe Peter, you've got some knowledge about that?
Yes, maybe you noticed that on the video we used the different cobots than we have here live. Yes, so we are able to integrate our scanners with many brands of many different robots. We already prepared integration with KUKA robots, with Universal robot, Hans robot, or Elite robot. So we can work with almost any robotic arm that is available on the market. Yeah, so maybe we can start the questions. We have the first question: how accurate is the alignment of the scans, and how can it be checked that it's not slipped?
So the accuracy of the alignment is, of course, dependent on the field of view, and it's natural, it's physics out there. So, for example, for the headline, like I was explaining a little bit earlier, then this alignment will be a little bit different. We are talking about like the probably dozens of micrometers out there. For the smaller objects, then we are able to talk about the single micrometers of the changes. And mostly, for example, quality station, when we've got 31 micrometers of the accuracy for the single scan, for the full rotation, we will be talking about, for example, 40, 45. It needs to be also tested, but there are actually appearing some of the, I would say, tools that will help us to, let's say what kind of the accuracy we are able to get from the full registration and full alignment. And in that case, it's the root meter squared value, RMS value, that are going to appear, something like the report, all the time when we are making some kind of the measurements and alignments. I think I can show it to you for a moment. So of course, depending on the scanner and the measurements, it's possible. Let me, for example, select a couple of those points cloud, like we can see out there in our system alignment, global, selecting 3 elements, align. It's like the totally free version. So we've got all of those reports. According to the RMS values, of course, they are not saying and telling you the direct value for the changes, but we can use them for the algorithms to find it out. So as you can see, there are some of the cases how we can use it. And going back for a second to the whole full object, we've got our data cleaned. We don't have any kind of the noises all around. And by transforming them to the triangle mesh, like I mentioned before, we are able to obtain much more data. And for example, with this small field of view and better accuracy, better scanning resolution, it's not an issue for us. And it's quite easy to detect, for example, dents like you can see out there. So all of those defects, scratches, or for example, signs on the surface of object, they are really well visible. And we are able to do it, for example, thanks to the sampling. In that scanner, it's going to be, let me actually show it to you. Let's zoom in a little bit. We are going to the control, distance, and we need to select, for example, 2 points. So we've got 82, for example, between here we've got 90, we've got, for example, over there 60. So average value for that scanner is going to be around 70 micrometers. Of course, it's dependent on the angle of the rotation, but that sample, there are some of the roughnesses on the surface of it. So that's what we are capable to do with the sample, for example, like this. Could you remind me, Peter, if those were, there was, I think, one more question for that part, yeah? About the accuracy of alignment, then with...
Yes, and how to check that it's not slipped. So
Okay.
that it's stitched together.
Okay, so there are many methods. I'm going to show you one of them, okay? So for example, out there, when we are working always on the points cloud, we can have all of those data visible, and we can select, for example, one of those data as a bright lighted. And the easiest way for the operator, there are more advanced, but it's just to show you generally how it looks like. We can find out if we have the equal value of those red colors, so the bright light informations about the sample, the points cloud, and the gray one that represent the rest of the points cloud. Of course, those are the informations where we are finding out some extra informations. If you would like to do it with the more accurate method, you can always make also the cross section for the data. So for example, let's look at our object maybe with this angle, and I'm going to make some small cross section out here and out there. Then we can select all of those clouds and new cloud from selected points. Okay, we've got it. Now let's switch off visibility. And now we've got the cross section of our lines. So the crucial part for that is going to be zooming out and checking if we have some kind of the overlays or if we've got one straight line. For any kind of the STL models, making the triangulation, it's always some kind of the simplification of the geometry of object. So you need to also remember about that. And all kind of the meshes are a little bit different than the reference objects. I think, of course, there are also possibilities to change the set and preparations for the triangle mesh also in our software. So for example, if you'd like to get here, select those data, maybe deselect that one, select, get to the triangle, create. You can choose between the raw data or optimized data. So it's also possible. So I hope that was a good explanation. So we've got a lot of methods, and I just simply showed you two of them. Okay.
Yes, thank you, Pavel. I hope, Daniel, I hope you got the answer. If you would like to go deeper with the details, please contact us. Here I will leave my email address. Okay, do we have any more questions? Yes. What are the calibration requirements for the scanners and how often do they need to be recalibrated?
Okay, so we are switching. Okay.
Yes.
So for the recalibration, in all of our scanners, we've got the motherboard made of the carbon fiber and with some special kind of the vibro isolators. And so most of the vibrations we are able to remove. And for example, they are not going to affect on the measurements. But sometimes it's happening that we need to recalibrate the scanner because of those vibrations were too strong. And then we are actually making this kind of the recalibration. So as you can see, it's not like we need to do it, for example, with the exact step of time. We need to do it when something happens. Sometimes some of our scanners that we've got in our headquarters, when they are actually set stable, they cannot be actually recalibrated, for example, 1 year. So it's not an issue out there, and they are still holding their accuracy according to the VDA standard. But if you are, for example, sometimes we are going to some of our customers, and not always the road is quite smooth, then we are simply making the recalibration. So for the standard environment, the measurement, for example, in the room or office, we are recalibrating to the scanner, for example, once per 2-3 months. There is also the possibility to check it. I'm not sure if we have time for that, but it's also possible. And we are making also the calibration pattern matrix standard for all of our customers that would like to recalibrate their scanners on their own. So basically, it's possible. We need to recalibrate not dependent on time, but dependent on the situation and the environment. And but for most of the cases, you can check it and do it maybe once per 3 months. So then it will be much easier to have the system ready to use all the time. I hope if something was unclear, just give me a sign, okay?
Okay, and we have another one from Alberto. Which VDI standard?
Watch them.
Yes, we have another question from Alberto. Which VDI standard do you consider? So we certify our scanner according to VDE 2634, part 2 or part 3. That's depend on if we are certifying mono scanners or stereo scanners.
Maybe I would like to add one last thing at the end of this presentation. I would like to mention one more thing about how we are positioning the scanner and what we are able to do with that. So basically, it's not, you don't need to have any kind of the programmist knowledge, because let me share my screen just to show it to you. You don't need to have any kind of the programmist knowledge. All you have to do is going to be simply getting to the template manager. Right now, when you press here, okay, I hope you can see the color on the flange changed from the green to the blue. And then we can, for example, make the new template, for example, 1, 2, 3. And by pressing save, we can change the position of this robot manually by our hands. So for example, I just need to simply change the position, for example, the angle. At the back side of the scanner, we've got the lasers. Those lasers to find out where is the middle point of the measurement volume. And we need to simply aim with those lasers on the surface of our object. If we will be happy about the position and the result, on the flash, we've got 2 buttons.
One of them is going to be to simply make the pre-scan, so like making the measurement and checking what kind of the elements we are able to see from that angle. And on the screen, we've got our informations and all of those data. And let's say that we are happy with the result. The second button on the flash allows us to save this position that are going to appear over here in the position box. So over there, you can see the position 1 was saved. Then we'll scroll down, we'll have information about the angle of rotation and angle of each of those joints. If we will simply press save, you can of course make multiple of those positions. So we are simply making the plan, measuring plan. When you will do it and press OK, robotic arm, because it's cobots, is going to always come back to the home position. So I wanted to clarify that one last thing. Just to mention that it's not really difficult, it's quite easy, and like I mentioned, you don't need to be the engineer or have really advanced experience, like a lot of experience in that matter to operate with that system.
Okay, we have no more questions for now. However, you are very welcome to contact us by email, for example. I just type email on chat box. You can email me or Pavel. We can also have one-on-one meeting, one-on-one presentation, and we can go deeper with the details if you have any questions. So thank you very much for attending this webinar. And please contact us. Thank you, Pavel, for this technical presentation and explanations. And I hope that we can stay in touch. And please do not hesitate to reach us out if you have any challenges with measurements.
Thank you too. Bye.
Bye.